We
So,
always start with this.
good morning, good afternoon, good evening, everyone, from wherever you join. Welcome to our SDV Coffee Talk. My name is Fatih. I have two wonderful guests. Florian is not any more guest, but he is still. I will present him as a guest, and then Felix.
An inventory.
Probably, yeah, but you could say this. Probably we can have a short introduction round, and then we can just try to start.
Yeah.
Florian, you want to start?
Yes, absolutely. I mean, I'm introducing myself every month now, but that's fine. So I'm Florian. I process consulting based in Las Vegas. I'm in the automotive industry for 20 years. Spent the first half of that basically in the traditional car making world at Continental, working for Volkswagen, Audi, building steering systems. 6 years at Tesla as a manager for vehicle level software validation, responsible for every software release that left Tesla between 2012 and 2018 to all vehicles. Spent a year at NEO as a director of integration of smart components. And then for the last, wow, time's flying by, 5 years now as a consultant and advisor around everything SDV. Let's keep it like that. Let's keep it simple.
Okay. Well, I don't have 20 years quite yet, but I do have about 15 in the automotive industry. I'm Felix. I started my career in the German automotive industry, also with tier one suppliers and services around the Stuttgart area. And I relocated to the US about 8 years ago. For me, it's been mostly focused on development tools, diagnostics, anything along those lines. And for the past 3 years, I've been managing the US subsidiary of Tracetronic. We're a company that provides a platform for software testing, vehicle software testing specifically. Maybe there will be some more snippets, but I'm really looking forward to today. So thank you for the invite.
Yeah, you're welcome. I mean, our today's topic is actually the latest and greatest news around SDV around the world. I think you both were in the last time often on conferences and so on. Probably we can just start talking about that a little bit. What was your impression? I mean, from the conferences.
I had and have 17 conferences this year. I'm not sure if anybody wants to top that.
Okay.
So some of them are short, like evening events and stuff like this. But yeah, 17, and I'm meeting with a lot of great engineers. And Felix and I are joining some of them together, and that's one of the reasons why I asked him to join here today. We've seen different. The world is a little different this year than it has been last year around all this SDV thing. So people are settling into the fact that SDV is going to be the future, and so on and so on and so on. But we also see a variety of topics around partnerships and collaborations, which I herewith defer to our next SDV Coffee Talk, where we have Augustin Friedel here. But also the way. I mean, last year, everybody was just like, oh, my God, we have to in-house everything, vertical integration. We have to do all the software development at the OEM. And this year, it looks a little different. And then the emergence of GenAI is also happening right now. We can probably talk about that a little later because I don't want to throw too many topics at once.
But is it actually a mindset chat in the change in the OEMs, or what do you think? I mean, is it?
I'm not sure if I call it a mindset change. It's more like an awakening. Suppliers that do software actually might know what they do, and we might actually utilize them as such. We can talk about that a little bit more into detail. But I don't want to cut Felix out right away.
Felix, yeah. What was your impression?
Well, one of the trends that I saw was that I always look at things from a testing perspective because or testing and validation, because that's what we're focused on, but that it still seems to be a big mystery of what needs to be tested to verify certain functionality. And that's not only for the software-defined vehicle, but also things focused on ADAS that goes hand in hand with the software-defined vehicle. There are still many companies building libraries of scenarios to validate certain driving scenarios, to certain driving features for the ADAS systems or autonomous vehicles. And it really feels still a little fuzzy. I'm not entirely sure if there's something out there that really covers everything. And that's just one aspect, but it's another one of those that Florian just mentioned, where the companies or the OEMs or the vehicle manufacturers themselves, they don't really have the knowledge or the resources to come up with that. So they are going out actively looking for solutions in that realm that make their life easier.
So what I see is actually that traditional OEMs are more open than ever, at least it feels like it, to work with new partners, and even with companies that are around for very short time, so startups. I talked with startups they just incorporated a couple of weeks ago, and they have a contract with Ford, right? But there might also be the other way around, that they actually talk with Ford first and then incorporate it after they got the go for it. But in general, what I'm observing is that the industry tries to figure this thing out. I think we can all agree on that. And they run into the wall, get some bloody nose for a while now. And by now, they are open to entertain, to work with some people they haven't considered before. Let me carefully phrase it like that. And there are new solution providers emerging, and also existing solution providers like Tracetronic, like focusing very heavily on this topic, to actually knock at the door and say, hey, you know what? You don't have to figure it out by yourself. You're not alone. And I think this was one of the major like takeaways from the SDV conference in Ann Arbor a couple of weeks ago. It's like, we have to go through this together. There's no one-stop shop who can everything. Not even Tesla does everything by themselves.
But what is the difference, actually? I mean, this is traditionally
Yes.
software is done in automotive, like you have a supplier and supplier is delivering. I mean, what is the difference now? I mean, with the partnerships.
If I may,
You may.
So I think the critical component is now that everything is being integrated into one system, maybe also with central processing units and still subsystems that need to function as one for the entire vehicle. You can no longer look at individual features as silos. So when it was mechanical, it was fine if everybody was off by a little bit, the car would still work. But now if someone is off by a little bit and they're being integrated into a central processing unit or into a highly networked vehicle, if something doesn't work, everything doesn't work, or there's the potential for things to not work. And I think that's what the tricky part is, that still needs good solutions. You can't just tell the supplier, test the hardness of your software and then deliver me a certificate where it says the software hardness is fine. That used to be okay for a mechanical component. It's not okay for software. And I think that's where the challenge is, and that's the challenge they're trying to solve.
But how this partnership should work, actually? I mean, who develops the software at the end? I mean, together, or I mean, how should this work?
So one thing I think it's very important, and traditional car makers and suppliers have to wrap their head around this, is like, don't do it in a silo. This is a huge problem, and the solution is open collaboration. So to get people to work together, and in a way they have access to each other's work as well. So to answer your original question, Fatih, you said, like, what's the difference between back in the day and now? Because it's still suppliers, just a slightly different product. But the difference is that back in the day, you had a specification, you created a subset of a product, and you sold it to the integrator, and they put it in the car, and it worked, hopefully. Now we're in this continuous everything, right? So continuous integration, but also continuous improvement, continuous development, and not even only by choice, but also by regulatory requirements. You have to do software updates, we all know, for like at least 15 years after the end of production, and so on and so on and so on. So we are in a world now where it's not as sequential as it used to be, but it has to be continuous. So we all know that, like, figure eight thingy, like DevOps and so on. And that, from my point of view, only works well if you tear down the walls. Don't misquote me on that, but especially with my wall behind me. Tear down the walls and work together. Who is in the end the one who writes the code? That's a case by case. I don't think there's a general statement. It's like all the code has to be written by that entity.
Okay. Okay.
Yeah, I can add a little bit more to that because it's one of the challenges that we're trying to solve. So there are so many great tools in this entire space. For you can start with code coverage testing, functional testing, hardware in the loop system, software in the loop system, simulation environments, and they all have their very individual strengths. And it's almost impossible to find companies that are able to cover a significant portion of all of this validation that needs to happen before things go back into the vehicle. So one concept that is being explored is can we tear down those walls, to stay within that metaphor, and enable our supplier to provide meaningful testing and meaningful validation before we start with the integration on the OEM side. So one thing that's happening now is that the tier ones are able to test against a black box. So they create models of, for example, a vehicle bus, and provide that model to a supplier, and the supplier can already do their regression testing as part of their development process. And once it meets those requirements that the OEM has given against the black box that the OEM has provided, and you deliver it, then you've already had the opportunity to fix a lot of the errors, and the OEM has the advantage of receiving a software deliverable package that they can start with, where they can start with integration pretty much right away. And I think
with
that
a high
that
confidence, yes.
Yep. And it's not going to solve everything, but it is a really good first step of incorporating them into that tool or into the chain of quality that needs to be met for the vehicle.
But
I think this is
go ahead.
I think this is fantastic, and it goes absolutely in the right direction. But it has to come also with the understanding that this model that is provided to the supplier has to be continuously updated, because it's not a one-time throw it down to the supplier and then they can test against it, because they this is one of the most important things. Is like the continuous changes happen everywhere. And yes, we all agree on shift left, test early, fail early, fix whatever your term is for that. But it has to happen in a collaborative environment, and that's what I meant earlier before as well. So it doesn't urgently mean that you have to open source all the code from every supplier to everybody else, as Felix said. But at least that black box has to be updated on a regular basis, so that you're not testing against yesterday's environment.
But how was it actually on this conference? I mean, this GenAI, everybody's talking about that. I hear there's also a lot of in automotive this topic. But if there were there any topics or presentations about the GenAI in context of the SDV or so?
So I was actually attending the AI conference, not the car AI conference, which is here in Vegas, and it's like from super interesting to super creepy. They have everything in the shelf, whatever. The creepy one for me was that you can actually teach an AI to act as like a loved one who passed away, and you can keep talking to your family member for many years. They react exactly the way they would. That kind of like shrugged me a little bit, but but from general GenAI observation, I think testing, and I hand that over to Felix right away. Testing is the first one to harvest GenAI lower-hanging fruits.
Yep.
Okay.
So anybody who's developed controllers or ECUs knows how difficult it is to keep track of naming conventions, signal names, software versions, etc. So one approach can be to train private AI models or large language models to recognize signal patterns or signal syntax to make it easier to define where certain signals are and build test cases out of them. We also have, we've seen Gherkin pop up. I don't know if that's a tool that everybody's familiar with, but it basically, as far as I understand it, kind of removes the step of going from a specification or a requirement to a specification to a test case, but it is a specification that also includes the test requirements. Florian, is that an okay description?
Correct. And for those who are not familiar with Gherkin, sit down. It's called cucumber.io. You can look that up. The standard basically uses a human readable wording, which is given when then. So given precondition, when condition, then expected behavior. And that can be interpreted by your test system as well. A robot framework, for example, is able to do that.
Okay.
Yes.
Exactly.
And it's
I mean,
all,
the
it's all
test
about,
logic is the test logic is, so to say, decoupled from the test system.
Yeah, but
Okay.
it means that if you write the requirement in that
Mm-hmm.
syntax,
Style.
you don't have to write a test case anymore.
Okay. It's already. Okay. You can
Yep.
The
reuse,
requirement is
so
the
to
test
say.
case.
Okay.
but
Okay.
it brings us back to an old problem that happened far before software-defined
No
vehicles.
requirements.
Getting everybody to agree on a syntax that everybody uses consistently. So again, it's as always, the data and what you get out of it is only as good as what you put into it. But if that rethinking happens and the OEMs realize that there's something that needs to be done, I think they have a real shot at optimizing those things for the future, as long as everybody sticks to it. So that is part of where large language models could be used. The other side is troubleshooting. I mentioned the complexity of those test systems earlier. And if you look at like full vehicle test benches where you have all components of the vehicle for full vehicle integration testing, you've got many different things running at the same time to create a good overview of your or a good representation of your overall vehicle. If something doesn't work there, the AI component can also be used to do troubleshooting, because we can kind of fingerprint the failure patterns that we're seeing, and maybe that failure is with the setup, or maybe that failure is with the test case, or maybe we can categorize it automatically because we don't need to look at 1,000 faults that are exactly the same. So I think big data and AI will help improve the quality, but only if the input variables are also considered when switching to something like this. And obviously, the OEMs are not going to want to put that information public. It needs to be private, and those models need to stay confidential.
I love that use case, especially large, complex hill systems, creating a lot of effort to keep them running and to produce useful output. And in our statistics, even at my Tesla times, we had 80% of the failures were test bench issues and 20% are actually software issues, right?
Okay.
And no, I love that idea to have like your AI, I don't want to call it co-pilot, but AI something, co-tester, that actually looks at the output of the test system, which can be a flurry of gigabytes that comes out there continuously, and just checks if that is legit. I love that idea. I also wanted to add, because there was one of my panel discussions a few weeks ago at one of those events, like test engineers love to bang on stuff and break it. They don't really like to write test cases, right? So because that's the boring part, and then you can finally get into the lab and you hammer on your product and you see what's broken. So GenAI is actually going to do that now. It's imminent, right? So you take your requirements, you put it into your large language model of some sort, and you say like, okay, please write me comprehensive test cases for target 98% test coverage, whatever it is, right? Or you say, look, I have this much time, so write me test cases I can write and I can execute. And then you say, just write them right into Python, right? I don't have to take the test case and write it into Python myself. Then, of course, how much do you trust that, right? I think we all had experiences with ChatGPT, for example, giving us wrong information, wrong facts. So my son asked ChatGPT once the history of cars, and ChatGPT consciously answered the car was invented in France. Nothing against French cars, but they were not the first. And so this kind of stuff, you have to be careful with the output. But at this said AI conference, there was a professor, and he actually had a pretty cool approach to fact check AI with AI. And he had different AI models running against each other. So we have still some way to go. But to have AI take the legwork to write test cases out of requirements, and then the test engineer expert review those, I think that's today.
But I mean, you described actually with the Hill system and so on, classical testing in automotive. Actually, what is the difference in SDV then? I mean, what should change? I mean, in regards of testing, if we approach SDV actually, a high level of SDV.
Yeah, at one point, component hills will disappear
Okay.
because you only have like system hills. Anyway, this Felix, I'll let you talk to this because that seems to be right up your alley.
Yeah, well, I think that the whole structure and architecture of SDVs in general is very much inviting to move to a virtual system. So all of a sudden, that's the shift left concept. You can test so much more before ever going to hardware, which makes those full system integration type setups all the more relevant because that's the last step after you've discovered everything else. But with virtual ECUs and co-simulation of virtual ECUs, you have opened up the door for very high quantities of tests to cover as much as possible. Florian, you and I talked about SOTIF recently. That might be a cool little excursion before I continue. But what the concept of SOTIF is, and
yes,
but I
yeah,
will
actually,
continue
I
here.
can for those who don't know exactly what it is. So SOTIF stands for safety of the intended functionality, and it complements the functional safety aspects, where functional safety looks into the situation where something in your system breaks and therefore has a functional safety effect. So if components break or something like this, you have a certain effect, and you have to mitigate that and supervise it and so on. But especially with autonomous or ADAS functionality, the system might work as designed, but it is not designed well, and it might run over a person or something because it thinks it's a fire hydrant, something like that. It shouldn't run over a fire hydrant either. So the idea there is that you have to mitigate that by testing those scenarios as much as you can. And there are the different quadrants of scenarios. So you have the safe and unsafe and the known and the unknowns. And so if it's safe and known, that's fine. It's a functional test. If it's unsafe and known, you can test the mitigation on your test system. If it's unknown and safe, you don't care because it's safe. But if it's unknown and unsafe, that's the one you want to tackle down. And the way you tackle them down is by just making more and more scenarios known. And if they're known and unsafe, you can mitigate and test them. So it's a little bit of a religious question, how close you can go to infinity by taking more bite out of it. But in general, that's the idea. It's like you have to add more variety of testing, at least where we are right now. I'm not saying that this urgently is the infinite future, because, personally, I think a person is also not tested against every environment and every scenario before they get the driving license, but they are just tested against the ability to process. But we're not there yet, right? With on the edge AI and stuff like this. So right now, for level 3 and maybe level 4 systems, we are at this channel that we say, like, okay, we have to make the number of unknown, unsafe scenarios as small as possible, and we do that by make them known and tested.
Yeah.
Okay.
And so that basically leads back into what I was saying earlier. The more you can test, the bigger the known area is going to be that you can actually work on. So if you kind of brute force a simple scenario of a vehicle driving towards an intersection, and you try that at different speeds with different weather, with different participants, you all of a sudden have tens of thousands of test cases that could potentially lead to a failure of the system or to a response of the system that you don't want. So the more you can test, the better. If that's limited to hardware, the hardware is not going to scale according to that number of validation steps that you need to take. So the virtual environment where you can do a lot of this, you can basically scale as far as your wallet allows if you're using a cloud provider like Amazon Web Services just for processing power. So a lot of this, and this probably leads back to something that you've maybe said in the past about Tesla, but when you have these release cycles that you're trying to get closer and closer together to deal with over-the-air updates and hot fixes, and making sure within a very short period of time to test your entire system before you deploy it to your users and to your customers, there is no way to do that on hardware. So that virtualized ECU environment, co-simulation, virtual testing in general, and scaling with parallel execution is going to be the only way to achieve that.
Okay.
Yep.
Okay. I mean, SDV is always associated with cars. I mean, if I hear SDV, I always think about usual cars. Is there any were there any presentation about also SDV concept in other
Yeah.
areas of mobility? I mean,
It's funny that you mentioned that. Somebody posted something about SDM or something like this, software defined mobility.
yeah. Mhm, mhm.
Yeah. So in general, yes. A couple of thoughts there. First, I've been at a Move in Austin last week, and Move is all about mobility, not urgently cars. So it's everything from micro mobility on a scooter to air mobility with a drone taxi to even larger scale aerial transportation, and so on. And it is interesting to see how the SDV approach is getting into those worlds, but they're not really visible to us in the automotive world. Um, Talking with some of my friends over at Cibros, for example, they're updating scooters in India like on a daily basis with over-the-air
Mm.
software
Oh, okay.
updates to
Okay.
improve the electric range. Right in China, the scooters are by law, I believe, electrified for 10 years already. They are getting OTAs. This is something very, very interesting. The other thing is that the regulatory requirements for cybersecurity, as we mentioned it earlier, actually just added two-wheelers and trucks as well. So they
Okay.
have to, as soon as you're online, means you're a cybersecurity threat possible, you have to deal with the fact of software and software updates. If that, I mean, is that directly SDV or not? I think that's a question for Moritz, who is not here. But
Yeah. Probably.
in general, go ahead, Philip.
Yeah, I think that agriculture and mining are extremely good examples of software-defined vehicles,
Okay.
I
because
just wanted to bring that up too.
there's
Yeah.
there's a few different aspects to that. One is the business model. So if you're a maybe tractor or harvester manufacturer and you have that technology base on your vehicles, you can do what Tesla does. You can sell an autopilot for the planting season, or you can sell like a new way of planting things, or you can give the owner more control based on the latest research of what is best, and that kind of creates this environment where you're utilizing and monetizing these subscription type services that are beneficial to the end user, and you don't have as many regulatory components to deal with. So if you're in an enclosed space in agriculture, there's a lot more that you can do autonomously with a lot less risk. That doesn't mean that you can be careless, but it gives you a lot more opportunities there. And I believe that I saw a documentary on John Deere. They don't really see themselves as a provider of agricultural machinery anymore. They see themselves as a technology company.
Oh,
And
wow. Okay.
and I believe in many cases they are much further advanced than you would think for an industry like agriculture, because the
But not in all
technology.
cases.
Yep, not in all cases, but the technology enables so many things that they wanted to find solutions for a long time. And now, when you think, or when you look at what the companies that they have purchased that were focused on very specific things that would enhance their systems, I would say that that's a great example of an application where software-defined vehicles made their way into an off-highway type situation.
Is there
So
already,
Felix
I
and
mean,
I,
in this, is there
go ahead.
already some autonomous
Oh yeah.
acting of devices on
Let me
or
pick up on that right away. So Felix and I, we've been at it's called the IVT Expo. It's the I don't even know what IVT stands for, but it's
Industrial vehicle technology.
yeah, okay. So
Okay.
off-highway and agricultural stuff.
Okay.
And it's super interesting because all those things Felix was talking about are there. Agriculture is autonomous for at least 10 years, but on private
Really?
property. So yes,
Okay.
exactly.
I
But
didn't
it's on
know that.
private property. It's
Oh,
basically
okay.
like your mowing robot or your Roomba, right? But now they are getting connected, and then suddenly cybersecurity plays in, and they cannot claim private property anymore, because if you hack a combined harvester and send them downtown, it's not private property anymore. But it's very fascinating. That's why I spoke up and I said not in all areas, because in some areas like the autonomy, they're like super ahead of the game. In other areas, and I would call it SDV in general, they have a lot to learn. So as an example, when I was on stage at the IVT in Chicago, right? It was in Chicago, yeah. I start and I ask Paul, it's like how many Tesla drivers we have in the room, because I usually call them out for a couple of questions. And in Silicon Valley, it's about 50%. In normal areas like Detroit or whatever, it's about 20%. IVT Expo, 0. Nobody.
Okay.
Nobody. And
Okay.
last year, I actually ran a similar poll and I asked, who knows what is SDV? And it was, I think we had 80 people in the audience. Nobody raised a hand. So there's a lot they are about to learn about over-the-air updates, about software in general, continuous improvements and stuff like this. But there's also a couple of things that are really cool and ahead of the game. One feature I personally love is like the drones that are scouting the fields, and they do targeted watering based on the drone captured pictures.
Okay.
So zero waste of water.
Oh, wow.
This it's just a simple example. The other one is that the autonomous combined harvester, the Mähdrescher in German, has a drone assisted navigation system. The drone is flying ahead and just checking is there deer or anything in the field that you actually have a problem to go through with the autonomous system. So all of these things, this is today. This is not future.
Okay.
This is really cool. And if anybody has the chance, everybody has the chance, go and look it up. What Felix said about John Deere, this kind of stuff. There's some New Holland and all of those guys. They have some real cool stuff. They're just outside of our viewpoint right now. And that's why we go to those events.
From the technology point of view, are these devices also complex as a car? I mean, with the ECUs,
No.
I mean, for example, in a usual car, you have 80, 90 ECUs or something like that. I cannot remember exact numbers, but
yeah,
how
it
complex
depends who
are
you
these
ask,
devices?
I guess.
It depends. Yeah.
A lot of it is also related to the attachments. So if you
Okay.
have a harvesting
Very
attachment, then there is a lot of technology also built into that then needs to interface with the vehicle. And there's one thing that you can keep out of your mind entirely when it comes to this, or almost entirely. The comfort of the driver is rarely a consideration. So whether it breaks hard or it breaks uncomfortably, or those kinds of things, I don't think that they are super relevant. They need to make it comfortable enough, but it's not really a focus.
The ergonomy of the joystick was very prevalent in the last event.
Okay.
Yep.
Okay.
And then maybe one more thing that's also a trend there, and I think that plays into the software-defined vehicle market very well, is the sheer number of displays for UI in general.
Yeah.
So all of the menus and the sub-menus and the diagnostics and the controls, much of it has been moved to displays because of what we've talked about before. If you do over-the-air updates and you want to add features, or you want to put in new harvesting algorithms or something along those lines, better imagine the image detection improvements that happen every year. I know those harvesters, they sort out the bad crop from the good crop. Those can be implemented over the air. And then the displays are the main interface for the operators with the vehicle. So that always needs to be a consideration of the tests that need to happen, and the thoughts about how to use one of these machines correctly.
So Felix, amend me here if I'm wrong, but I believe in agriculture there's actually a definition of the interfaces between the attachments and the tractors, right? So there's a protocol that defines how you talk to each other, so that there's no also, supplier. So you basically you can take a John Deere tractor and you replace it with a New Holland tractor, and your whatever tool you attach to it still works exactly the same way.
That's also a little bit of an interesting excursion. Another one. In Germany, it's very common for a semi-truck, let's just use that as an example, to be manufactured by one company. That company builds the chassis, the engine, the transmission, delivers the whole thing. That's pretty common for us in Europe. In the US, you have multiple configuration options. So maybe you want a Cummins engine, or maybe you want an Allison transmission, or you want something completely different. And because of this variety of things that you can pick, especially in the heavy duty sector. They standardized on something called J1939, which is a CAN-based protocol. Behaves a little bit differently than regular CAN or OBD diagnostics or UDS, but that has a set of signals that is used across all the different manufacturers, and they each have their own basically message space that they can use for their own custom signals and diagnostics. But that is part of it, and it's extremely it's still relevant, and it will continue to be relevant because part of it will be CARB mandated for like clean truck testing, and fleet operators need to test based on that to make sure that their trucks are clean, and so there's a lot that goes into that.
It's a super interesting topic because I mean, we all originally growing up in Germany, we don't understand this how it works here. But yes, you order a Ford truck, and you said, "Oh, I don't want a Ford engine. I would like to have a Cummins engine in there." And Ford happily provides you that vehicle off the factory with a third-party engine.
Oh wow! Okay, but why?
Yeah.
But why? I mean, what is the reason?
Because Ford apparently, I mean, Cummins engines are famous for diesel, right, applications. So it's basically
okay.
But it's a different company. The other thing is I didn't know before I moved here as well. You can, on the website of Ford, you can just order an engine. I think you can go on the Porsche website or Mercedes and order the engine, right? So I did that because I built my kit car project 10 years ago. I went on the Ford website and I ordered a 5-liter V8 from Ford in Dearborn, and they sent me a crate and put it in my driveway, just an engine, right? And that's the thing. The other thing is we're drifting away a little bit, but you can actually buy rolling chassis here. So if you say, "Oh, I want to buy a shuttle bus," you go on the website of Ford or to your Ford dealer, and you buy a Ford E450 chassis. That's just the driver's seat, and the bottom part of the car is a V10 engine in there, which is a terrible idea. But and you can put in the back whatever you want. You can make your ice cream truck out of that, or you make your airport shuttle. But you can just buy that half a car here. I've never actually. I think you can do that with Volkswagen Nutzfahrzeuge. You can buy a Volkswagen Transporter, only the front piece.
But I think that's how the skateboard concept evolved for the new electric vehicle manufacturers. They have the skateboard, and it's really just the battery, the drivetrain, and some rudimentary driver cabin, maybe not even that. And then that goes to a chassis builder, and they can put anything from a fire truck to a tow truck to an RV on there. And it's an interesting concept, especially when the skateboard provider also wants to provide more features, because some of them deliver a basic set of ADAS features with their skateboard or other things. So but definitely a detour that we took here.
I mean, this electrification. I mean, we talked about this also. I mean, this was over sometimes we talked about this in the whole conversation. How important is this electrification actually in context of SDV? I mean, is it possible having an SDV with the classical engine? I mean,
yeah, it is. It's agnostic to the powertrain. The reason why we actually see electrification and SDV usually put together is because the electric powertrain is much easier to develop and implement. So we see the new players that have a much more focus on software, just using their electric powertrain. And therefore, there's like the natural combination. So Elon at Tesla once said, rightfully so, that we didn't intend to build an electric car. We did intend to build the best car that happened to be electric. And the software on top of it, because you can control electric powertrain much nicer than ICE powertrain. But I could easily build you an SDV out of a diesel truck. If there's a market for that, that's a different question. And for sure, for new players, it's much harder to get into the market using ICE engines, and therefore the electrification and the skateboard concept just comes in very handy.
But I think in the classical engine, I mean, is harder to maintain remotely. Actually, you know, I mean, it's much more complex, and it can fail also. You know, but an electric engine is quite simple. I mean, compared.
That's right, but it doesn't mean that SDV is exclusive to electric cars.
Yeah, this was exactly my question.
It makes much more sense. Yes, agreed.
Okay.
Yeah.
Okay.
That I guess, poses an interesting question. Where does a modern vehicle end, and where does a software-defined vehicle begin?
That's
Do
for
you have a
Moritz.
metric? Yeah, that's for Moritz. Okay.
He has an overview of that, the 6 levels of SDVs.
Okay. All right. Because it can connect an app and it shows you how full your gas tank is, I don't know if that makes it a software-defined vehicle.
No, that's probably level 2 on his scale.
Okay.
But that's right. I mean, looking at what is an SDV, you ask 5 people, you get 6 answers. I mean, that's for sure. But my usual take on that is just like, okay, you have the car providing features as a whole and not as a conglomerate of components. And how you implement that, you can, I mean, to be fair, Tesla's original Model S was distributed architecture. And it was still what I would consider an early SDV, because it had features provided to you as a car as a whole, but it had distributed ECUs all over the car, just handled in a different way. So it's not even, as I say that, it's not even purely dependent on the architecture. So you could probably build an SDV out of a 2010 Mazda Miata if you put a proper software stack in there.
Yep.
We should do that, Felix. For the racetrack.
Track car. Software-defined track car.
Software-defined race car. I like it.
Yep. Okay.
Anyway, I'd like to bridge over here to another topic we talked about briefly before, the famous decoupling of software and hardware, because we hear that at every conference, right, Felix? I mean, there's almost no talk on the stage that is not talking or mentioning decoupling software and hardware, but it doesn't really explain exactly what that means. And I think there's a little bit of misconceptions out there what it actually means. So I tackle it from a different point of view. So traditionally, you develop your product, software, hardware, mechanics, into start of production, and then start of production, you start selling the product, you move your teams on to the next product. You can't do that anymore, obviously, because of the UNECE requirements, but also because of the customer wanting more features on existing products. So you have to have your software continuously evolving on existing product. Then the typical feedback you get from the OEMs is like, oh my, then I have to hire 10 times the software engineers, because else I cannot tackle the new product development and the old product development or ongoing. And this is exactly where I take the step on the decoupling software and hardware. The software should not be targeted on the vehicle. It should be the software for the company, maybe for the platform, but ideally for everything. Tesla, for example, has one software that runs on all 5 models, and it's based on 2012 software. So it's an increment and improvement on that. And it's the same software going out today over the air to a 2012 Model S that it is going out to a 2024 Cybertruck. Of course, there are different varieties in the code and different hex files and so on, but the package is still it's still incremental and it's still the same. So my statement on that is decoupling software from the hardware, not only physically, but also team-wise. Decouple the software team from your hardware product and have them basically provide the software in general for your product portfolio.
But was it in the Tesla case really that the ECUs were able to run also in a virtual environment? I mean, that they were completely decoupled from the hardware. I mean, because I know, and also in talks with other friends from OEMs and so on, that the problem is that the software is tightly coupled to hardware. You know, it's hard to separate. Actually, I mean, it's not so easy.
Yeah, so I think it's a little bit a question of definition what the software is. So when I say that the Cybertruck has the same software as the Model S, that does not mean that they run the same code and the same hex files. It's just there's this concept of a software package, and that comes out of your version management, variant management, and so on, and release management. And that contains a variety of software code in there that can serve either or. It does not mean it's the same code running on those cars, but it's the same package that actually goes out to all those cars.
Okay.
Yeah, I can kind of take that validation approach again for that very same topic. So part of part of the challenge is, one, dealing with all those different tools, all the different hardware, all those different environments that need to be a part of the overall validation process. And if you are trying to automate and test efficiently, there is no way to redo everything every time that you move into the next stage of development. And when I say stage, it's like we start somewhere in a model environment, and then we increment, and we eventually get to like vehicle level testing. And one of the main approaches that we follow is that the test cases need to be independent of the hardware. So you have an abstraction layer where you define your tests, and it happens the same way that Florian described it for his example. You sometimes have things that only happen when certain conditions are met. Maybe there's no point in testing something in that version because that version doesn't support it. Or maybe that variant of the vehicle, you can skip the test steps 60 to 77 because it's a feature that's not relevant for the vehicle. But if you design those things to be reusable, and if you design them to be universal, then you are saving yourself a lot of time. And I think it's that exact same concept described for how the vehicle operates, decoupling software from hardware, to the development process, also decoupling from the tools. From you need to make sure that your requirements are met, but how you validate that should not be dependent on a single tool or a single environment.
And I think take the bridge back here to the device we are just looking at right now, which is a laptop. And the developers of StreamYard, which is the tool we are using right now, I'm fairly confident they did not test that on my hardware before they gave me that software, right? So Felix had the magic word where the abstraction layer, or HAL, right? A hardware abstraction layer. That means that the software, that feature providing software, high level software, however you want to call it, or in Silicon Valley, it's actually software, because everything else is firmware that controls the hardware. And that is independent of the hardware, and it actually, from validation point of view, that's massive, right? So if you don't have to validate the software running on each hardware, but you have a team of firmware developers, they are validating the controls of the hardware and then provide you an API, and you can use that on top of that. Very similar to what your Windows or Linux PC looks like right now, or Mac, because there's hardware drivers, and that's the term, right, they use in the computer world, which is technically the firmware of, I mean, my hard drive has a driver that allows Linux to talk to it. That doesn't mean that this hard drive has been validated with my Linux system. That's
another great segue to standardization, because there are organizations that, when I started in the US 8 years ago, I think I talked to GM, and they're like, we have GM LAN, and that's our diagnostics. And I was like, well, what about UDS? And they're like, don't know, don't want it, don't care.
Wow.
And now throughout these last few years, and this is just an example, they have caught up with what everybody else is doing. But now you have these standards, and ASAM is one of the drivers behind that, where you have open scenario formats where driving scenarios are written in a standardized XML format. You have communication protocols that are standardized. You have structures of messages that are standardized. There's a lot that's been happening, and that's also a key contributing factor, in my opinion, to make all of this possible. If everybody kept doing their own thing, and that doesn't mean that everybody is 100% on standard, because there are variants and flavors, but if everybody follows that general concept, it makes all of these things that we've talked about so much easier.
Yeah, it comes a little bit down to leading versus following, right? So if you go, and we see this, charging is a great example, charging EVs right now, right? So Tesla took on the lead because there was no standard, or OTAs, same topic, right? There was no standard. And then now, after 10, 12 years, they made the Tesla Way the standard with NACS, or actually the SAMS, software update management system, is basically a blueprint of Tesla's OTA updates. So you can either wait and do the standardization, as you just explained, take the standardization, which is great. It's nothing wrong with that. Or you take the lead, but then you take the risk that you actually get a solution that's outside of the standard, and then you are actually you're not part of the game.
Is there any activities actually on standardization of hardware? I mean, this is all also a pain in the automotive, that every time hardware is developed from scratch, new
Yeah.
for the same thing. This is such a. I was talking to a couple of people about this topic. I think this is like in this laptop case. I mean, laptops are also, you don't care about the hardware anymore. This is more or less standard. I mean,
Yeah.
this is
You're
not.
right.
All Macs are more or less the same. All, I don't know, ThinkPads are more or less the same. There is no big difference, but I don't see the same efforts actually in automotive.
Partly. I mean, we've seen it a long time ago with DIN radios, which are highly highly standardized. So your radio and my car radio are the same slot and the same interfaces. But other than that, I see where you're going, and I have not seen great approaches there yet. I have talked with a couple of startups who are thinking about, for R&D purposes, to do more like generic ECUs that you can use FPGAs, use things like that, and modify larger piece of hardware that they behave exactly like a custom-made hardware. I don't know, Felix, you're probably much deeper into that world.
Well, on the hardware side, it's very difficult to say that there has been a significant progress. I know that with some key players entering the market for controllers specifically, or like the silicone that's in there is consolidation, and there probably won't be quite as many variants in the future. Where we have seen significant progress is in that virtualization space that I talked about earlier, where things like functional mockups, FMU, is now a standardized description of a virtual ECU and how it's supposed to behave. So a common interface to work with a virtualized ECU. There are still companies that are needed with their tools to see how multiple virtual ECUs interface with each other and simulating the network traffic and all of that. But at least on the virtualization side, there does seem to be standardization, but that doesn't necessarily help with hardware just yet.
But we talk with a couple of approaches or people who have approaches to offer this as a service even, right? So processor in the loop in a testing farm on a certain, service center, and you configure it in the virtual environment to be exactly your ECU before you have your hardware available. And then you run your tests on that server farm in the virtual environment on the real chip, but with with simulated peripherals.
Yeah. It's like,
Okay.
hardware in the loop or processor in the loop as a
Still, yeah,
service that you would,
PILAS.
just like you would
PILAS.
reserve and utilize cloud resources for processing, you can then utilize these hardware farms of different controllers and chips and test systems to do your testing.
It's a little bit like similar what the AWS approach is like, hey, let them do the scaling, so I don't have to take care for my utilization of my test systems. I let them do it, and if there's a tenfold need on my side, I just pay more and I get more resources, and then I ramp back down when I don't need them. And AWS or whoever is on the other end of on the receiving end, it's their responsibility to scale the resources because they know about this stuff.
Yep.
What about the cybersecurity, actually? I mean, if we talk about connected cars, I mean, SDVs should be connected always 24/7 and whatever. I mean, this cybersecurity becomes more and more important. And were there any talks about this topic? I mean,
yeah, I personally believe the big one hasn't happened yet. So the big cybersecurity attack hasn't happened. It happened recently here in Vegas last year. It was the hotels. So there was like this $80 million ransom money from MGM Grand and Caesars and stuff like this. They didn't make it very public on purpose, but it happened big time in that world. And since then, the cybersecurity efforts ramped up significantly. Now, cars is actually even more dangerous because they move around with a lot of kinetic energy. And if you can actually hack them in a way that you control, like there are a couple of science fiction movies that deal with that topic. Don't want to go down in that direction, but I think there's a lot we don't know yet. I think that let them call the dark side, the hackers. They're much better in technology than we are on the bright side, on the white side. They use AI in a way you haven't even thought about. And I know a couple of those like white hat hackers. When they started talking what they are doing just for the fun of it, it's unbelievable. And my statement, and then I hand over to Felix, but my statement is always, those guys don't agree to code freeze and feature complete. So just because you can prove that your system is secure today, it doesn't mean it's secure at all tomorrow.
Mm-hmm. Yeah, we've I think for us, the challenge started probably 12 years ago. That was when BMW started implementing automotive Ethernet in their vehicles as one of the first. And as soon as you utilize a protocol or a network or a transport layer that hackers from the PC world know already, you are not going to be capable of keeping up with the advantage that they already have.
You're basically
So,
running into the open knife,
right, correct. So these last few years, and it stayed somewhat quiet for a while, but these last few years, we've gotten more and more requests to do the cybersecurity, the seed and key procedures, the everything that relates to being able to access a vehicle system as part of the validation process to see if it behaves appropriately. I don't know if that covers all of the use cases and all of the bad thoughts that the bad hackers have.
It's
but-
going towards infinity again. So that's
Yeah.
the thing, right? So, but the thing is also that the technology evolves continuously, and even though your product is the same, the malicious attacker has new technology and new tools available by the day. Fatih, we should actually, in one of the future episodes, we should talk really deeper into that. I know a guy we can invite for that, who can really get
I mean,
some deeper.
I'm asking this because, I mean, okay, if we consider AUTOSAR classic, this is quite very, you know, nerdy technology. But if we go for AUTOSAR adaptive, this is Linux-like, you know. I mean, then you have a lot of people knowing the knowledge in this area, and I think it will be much more easier to hack a HPC as an AUTOSAR classic ECU. You know, I mean, and if this is connected all the time, I think this is especially for, you know, I mean, people, they want to do bad things. It's easy to access the car. I mean, where you control almost everything. You know, I mean.
So I have a great anecdote for that as a closure. But Felix, you want to
Well,
go first?
I was actually going to ask you about this. So I had one of the early Model 3s all-wheel drive in 2018, I think, and I found out through forums that the motors were actually the same based on the serial number as the performance model. And there was, and I would say that Tesla was pretty far advanced in terms of vehicle networking and cybersecurity and all those things. There was a little shop on the East Coast that could recode your all-wheel drive Model 3 into what was
Crazy,
faster,
really?
what was faster than a performance. And all they needed was one access point in the glove box, and they figured out how to get there. And that's where I would say that was early in that stage, and they still.
I would be careful giving those people money, because with your next OTA update, the configuration is probably wiped. But yes, actually, that opens a whole new market, black market, for tuning, quote unquote. I mean, chip tuning is not different, right? So what did you do back in the day with your TDI engines? You put a new array of data in there, and you basically, you know, you had a 90 horsepower motor which was capable of 130, so you just changed the field of the array. But so just to and that's my closing comment, because we're reaching time. Just to entertain and to close this with an anecdote. So we used some open source in the infotainment system at Tesla, and in the R&D phase, we figured out if you take the Nintendo proprietary theme of Super Mario World in their own format on a USB stick and play it in the media player of the Model S, the system opened a port that you can actually talk to the vehicle gateway. Two questions on that is like, who in the world comes up with that? And then even more questionable, who in the world comes up with a test that finds that problem?
Yes, it's crazy.
I don't want to know what else they tested. Obviously, Sonic the Hedgehog didn't make the cut, but yeah. So this just hackers are usually very nerdy people, so they come up with some really quote unquote fun ideas.
Yeah, we reach actually our end. Thank you for the nice discussion, Felix, Florian. It was really interesting. Yeah, some closing words from you guys.
I'll stay with my Nintendo.
Okay. With your Nintendo. I want to maybe leave one item with everyone who was listening. What will happen in the next few years, at least from my point of view, is the collaboration is going to need to increase by a lot to make sure that all of these things are covered. And closing off systems or trying to do your own thing, in-house developments try to focus on the things that are important to you, become really good at those, and look for the right partners that can cover the gaps. No one needs to do everything. There's a lot of clever people in the industry, and I hope to work with a lot of them in the next few years.
Awesome.
Thanks.
Yep.
Thank you. Okay.
All I
Thank
hear
you.
is
Yeah.
Bye.
See you guys.
Okay.
Bye.
Yeah. See you next time. Bye. So.
All right,